Alright, welcome back to session 2 of making a simple platformer here. So just want to walk through where we left off last time. So we should have a tile map in our game that has our tiles. We created our tiles, we put them on a tile palette here, and then on our tile map we added the tile map collider 2D. This, we see it added all these little green boxes around each of the tiles so that we have a collider here. And this will give us some place for our player to land. We see I have a different tile map up here that doesn't have a collider on it. See the difference? And then we also created something of a player, just an object in the game that will, if we push the play button at the top of the screen, it will fall and it will land on that platform. We achieve that by adding the circle collider to our player here, as well as the rigid body 2D. So both of those components are necessary for it to fall and to collide. If we don't add the collider component, then it won't collide with the tile map. And if we don't add the rigid body, then it doesn't have anything over here that tells it how much gravity to use. We see here it has a gravity scale of 1. So right now it's falling at a rate of 1 gravity. So that's where we left off last time. This time we're going to do something a little bit different. We are going to create a script for our player movement. Now this movement is it's not something that comes with Unity, so in order for us to do this we have to actually write a script to do it, and then we will attach that script to our player in order for them to move. I just want to remind that the rigid body 2D is the component that allows all forces to act on the player. So if we want to move the player side to side, then we're going to do that basically by pushing this ball side to side based on user input using the rigid body. So that's sort of how we're going to go about this. But one more thing that I want to do before we get into that is I want to show how to make it so that the camera will actually follow the player. Because right now if we push play, we see that the ball just falls and the camera doesn't follow them. So it's very, very simple to do that. In the hierarchy over here on the window on the left, we are going to select the main camera and we are going to drag it onto our player. In fact, I'm going to rename my player right now so that it's more clear what this is. There we go. So I have player, and then we see that the main camera is called, this is a parent and a child. So the main camera is a child of the player. So now if I push play, we see that the camera will fall with the player. But we see that it's a little bit weird because the camera is offset. Right? It's like the player is really high on the screen here. This is because the camera's position, if we look at the transform component over here, the camera's position on the y-axis and the x-axis are a little bit off. Right, so if we want it to be perfectly centered, we say x of 0, y of 0, z of negative 10, remember, because z is sort of going in and out of the screen here, so we want it to be z of negative 10 so that it is out of the screen. And now we'll see that the player is properly centered. Okay, so you might notice I have a script down here. This is the one that we actually covered in the class. So we're going to create another script down here in the project folder that is going to handle our movement. So we do that by right-clicking, or we can click on the create button right here. We're going to right-click, say create, C# script, and this is really important. Java update is not really important. This is really important that I just made the mistake that I was going to warn you about. So I didn't name my script before it went away. So now we see that this is just named a new behavior script. I don't like that, so I'm going to delete that and I'm going to try again. So right click, create, C# script, and I'm going to call this player movement. And the way that I name this is really important. So I'm not including any spaces in the name of this script, and I'm capitalizing the first letter of each new word. And we'll see why that is in just a minute. So if we hit enter, then it will confirm the name of that. And we see a preview of our script will show up over here on the side. Okay. If we hit enter again, then it'll open Microsoft Visual Studio. And in Visual Studio, we will see our actual view of our script. Now you might have to, if this is your first time, you might have to create a Visual Studio account, or you can set it up later. Okay. And we see right here that at the top of this tab right here, it says player movement is the name of this script. I'm gonna, spoilers. Okay, and right here, the name of the class is player movement. Okay, public class player movement. Now these names have to match, and I said that we didn't want to include any spaces, and this was for a very important reason. See, if I put a space in here, this name is pulled from when we create the script. So if I put a space in here, the script thinks that its name is player. And then this space means something in the code. It means that that is the end of the name. And then it moves on to the next thing. It says, I don't know what the heck movement is. And so we get all of these errors because it doesn't know how to process this. Because this colon also means something and it thinks that it's in the wrong place. So we don't want to have spaces in the name of our scripts for that very reason. Okay. Now, we're going to do the thing that everybody does as their first time in a script, which is a simple hello world. So we're just going to right here we're going to say debug.log parentheses quotation marks hello world and semicolon at the end of the line. Now it's really important that it is exactly like this: capital D debug, capital L log, and that our words be inside the quotation marks in the parentheses. This is because this is a variable that's called a string. It's a string of characters. It's characters that are all put together. So character capital H, lowercase e, lowercase l, so on, all put together. So it's just words. That's all that a string really is. And this is basically telling Unity that we want to spit this string out into what's called the console. I should also mention that I've just put this line of code inside what's called the start function. The start function is run, this comment right here tells you when it's run. It's run before the first frame of the game. So it's when the game is doing all of its setup, it's going to run this. What that means is that start runs once and only once. We also see that there's another function down here that's called update. This function runs every frame. So if you have like a really high frame rate, then this function will be run many times. So this is default is 1/60th of a second. So 60 times per second update will be run. I also want to talk about just sort of the way that this script is laid out. So this stuff at the top, this allows us to interact with Unity game objects and components and stuff like that. This is like I said before, this is the name of the script. Scripts are also classes, referred to as classes. And then classes have what's called encapsulation. C# uses an encapsulation, uses curly braces to show encapsulation. So we have an opening curly brace here, and then we find all the curly braces will always have a buddy. So there's an opening one here, and then we see that there's a closing one down here at the bottom. Functions also have encapsulation, so opening here, closing right here. Update is another function. It opens here and it closes down here. Easy way to check and make sure that all of your encapsulation is good is by clicking on the closing curly brace, and it will show you where its pair is. So if we throw a rogue curly brace in here, then what's going to happen is this stuff is going to error because it says no, we can't have code outside of the class. This is no man's land. Okay, we can't have this code outside of the class. It needs to be inside the class. It needs to be inside its encapsulation. Okay, so what we've done by writing this line of code right here is we have put this line of code inside starts encapsulation to make sure that this code runs at the start of the game. Okay, so if we save this, we press Control S, it'll save. And we need to go back to our Unity project, and we need to attach this component to our player. really easy to do this. We can just drag the script onto the player down here, and it will apply it. We'll see that it says player movement script right here. And if we have any errors, they will show up in the console. If you have errors, then you need to make sure that all of the code matches exactly what I'm doing right here. Okay. Now if we push play, what will happen is we'll see in the console it'll say hello world. That is because this line of code right here, this debug log, is telling Unity to write this hello world in the console. Okay. So that's what's happening right there. So we just wrote our first script. It doesn't really do much, but it does something. Now let's before we get too far into this, let's talk about the different types of variables that we can have. So we can have variables that are integers. So those are just like whole numbers, like 27. And what I've done right here, this is called declaring a variable. So I have created a variable that is of type integer. This is its name. I've named it number, and I've set its value equal to 27. And you'll note that each of these lines ends with a semicolon. That's because when Unity or whatever is using the C# script is interpreting this, it will read down from top to bottom, and it will look at this line of code, and then it will get to the semicolon and know that that is the end of its thought. And then it will move to the next line, and it will say, okay, I have a new command that I need to run. I'm going to create this new variable that's an integer. Okay, what's the name of the integer? Well, I've chosen to name it number. I could name it Fred if I wanted to. I could name it, Georgie or whatever. Usually you want to name it what makes sense in your game. So like, an example of an integer that you would have is like your health, right? You want that to be a nice whole number, or your character's level, or your experience points, or something like that. Okay. The next variable that we want is called a float. So floats are basically decimal values. They're a floating decimal value. Basically, it determines how many decimal points it'll go to before it rounds. And these are things that are, so I'm going to name this crit chance. So my chance of getting a critical hit or something in my game. So I'm going to set that to a 10% chance of getting a critical hit. And the thing about floats is you always need to end them with an F. So you say 0.1 F semicolon. Okay. So floats, just something that stores a decimal value, things that are like probabilities, chances, and stuff like that. Okay. The next variable we've already talked about before, so that is a string. And strings are often used for storing variables like names. So I'm going to name my character Cloud. You can name them whatever you want. Okay. Again, this is a string. It's words. It could be anything like dialogue or names or anything like that, types of weapons and that sort of thing. Now the last one is a really simple variable, but it's actually one of the most important. So it's called a Boolean, and a Boolean value is just a true-false value. So Booleans are used all the time because we have to deal with things that are like, if this condition is true, then we perform this other action. So thinking about if I hit level 10, then I can now go into this new zone or something like that. So that's it's one of the most important things that we have in programming, because we want to have these conditional statements that are based on these values. So really important. Okay. So now we know some of the different types of variables that we can use. We can actually start to think about how we will use this in our game. So if we think about our game, we should think about how we want to handle movement. Now, Unity, fortunately for us has a built-in sort of mapping of some of the different types of, oh, it's right here, different types of input that we might want to get. So I don't know why this isn't letting me resize. There we go. So there's this input that's called horizontal axis. Several different keys. So we see that it has the left and the right key, as well as A and D. So these are the keys that are actually going to control our player's movement when we actually get the script to work. So it's really, really nice that we don't have to hard code each of those things into it. We can just get all of the horizontal input and interpret that value. We also notice that there's something down here called jump, and if we expand that, then we'll see that there is a space button. So that means that if we press the space bar, then it will cause our character to jump if we have coded that into our script, which we will. Okay, so what we are going to do in our script is we are going to come down into update now, because we want our code to be looking every single frame if we're getting user input, and we're going to start to program the movement behavior of our player. So the first thing that we need to do is we need to check and see if we're actually getting a sort of input from the player. So we're going to create a float x, which is going to be equal to input dot get, and you see as I start to type, it'll the autocomplete should come up, so it'll try to guess sort of what you're trying to type here. Once we get what we want, we can actually just press the tab key and it will autocomplete for us. So we're going to do input.getAxis horizontal, and this is going to check to see if we pressed either the A or the D key, or the left arrow or the right arrow, right? Those buttons that we just looked at in the project settings. Okay, so we've basically gone out and we've made a copy of this value to check to see if we're getting any sort of value, and we can look at what this is by doing a debug log of x and switching over to our project and looking at the console after we push play. If we press A, we see that it goes to -1. If we press D, it goes to +1. So what that tells us is that this value, this horizontal value, is changing. We put a comment in here that tells us x will range between -1 and 1, +1. Okay, so this is really great, because that means if we hold the A key, the value will be -1, and we want to move in the negative x direction, so we can just apply a velocity to our player in that direction and it'll work. So that's actually really nice for us. So we are going to do that now. Now, if we think about velocity as it relates to us and our player in a 2D game, we actually care about velocity on both the x and the y axis. We care about the x axis because that's what's determining our ability to walk side to side, and we care about the y axis because that's affecting our ability to fall and stuff like that. So that is actually two different floats, and that's stored in a special kind of variable called a vector2. Okay, vector2s. So I'm gonna vector2s are, or vector3s. We've actually seen them quite a bit. So anytime we see something like position, we see that this is a collection of three different floats. So that is a vector3. A collection of three different floats is a vector3. A collection of two different floats, like in our velocity, that's a vector2. So all that it is just bundling, similar floats together. So this is going to have both our x and our y velocity together, and it's going to store it in that variable. So we're going to set that equal to, and this line of code is a little bit tricky to understand. I'll walk you through it once we get typed in. We're going to say get component, the less than symbol, rigid body 2D, greater than symbol, open closing parentheses,
dot velocity. Okay. Okay, so this is a little bit tricky. It looks pretty complicated. So it's actually not that bad once we get used to this syntax. So the first thing that we need to recognize is that right here we're going to be getting a component on the object that this script is attached to. So we're going to attach this to our player. So that means that it's going to get the rigid body component on our player. Now, get component is a function, just like update and just like start. Get component is a function, and all functions have these parentheses. Okay, so after we get component, we have to include the parentheses because all functions have them. We'll talk about why, what the parentheses do a little bit later. And then once we get the component, our rigid body actually has a variable on it that is the velocity. It's how fast am I moving at any given time. So we can go out and get our velocity and store it in this variable locally. Now this is really important. This is making a copy of our velocity. This is not storing a pointer, or it's not like keeping a reference to this velocity. It's storing a local copy in this script. So what we're going to do is we're going to go out and make a copy of it, change this velocity, and then send it back to our rigid body. So that's what we're going to do. So we've gone out and we've made a copy of it. We've said, how fast am I moving right now? Then we need to change it. So we're going to say velocity.x equals x. We want to change our velocity in the x direction to not be whatever it is previously. We want to set it equal to this x value, which is our input, right? We want to change our x value based on our user input. Okay, then we can just do get component rigid body 2D dot velocity equals our local velocity, that copy that we made. Okay, so we went out, we made a copy of it, we changed it, then we send it back. Okay, simple enough. We can Control S to save that, switch back to Unity, push play, and we should, well, I'm moving, but my camera is spinning around my player and I want to hurl. So this is a funny sort of relationship that we haven't really encountered before, and that is our camera is spinning. Our camera is spinning because our player is round. And when we apply a velocity to a round object, the round object is sitting on this tile map and it has friction. So when we push it, it is rolling in that direction, and our camera, which is parented to our player, is also rolling. Because anything that happens to the player also happens to the camera, right? Whenever the player moves, the camera moves. Whenever the camera or the player rolls, the camera will also roll. So that's on the player. We're going to go to the rigid body component, and there's a little section in here that's kind of hidden. It's called constraints. We're going to expand that, and we're going to tell it to freeze rotation on the z-axis. Remember, z is coming out of the screen and going into the screen, so we want to freeze its rotation. It won't rotate on that axis, and then if we push play, we should see we can move side to side. Okay, so that's pretty neat. But I can't jump. I move pretty slow. There's several things that we need to fix with this. Okay. Moving slow. That's really easy. We can fix that really easily. And we can fix that in a really clever way so that we don't ever have to deal with that issue again. So what we're going to do is we're going to come up at the very top. We're going to come right inside the encapsulation for our class, and we're going to create a public float move speed. I'm going to set that to 3. Okay, so I've just declared this variable, this move speed variable, and I've made it public. This public flag is really important. This allows it to be visible in the inspector. So if I save this and I look in the inspector, now we see move speed is a variable that we can change, just like any of these other variables that we see in the inspector for any other component. If I want my move speed to be 5, I can just change that value right here. Okay, I don't have to open the script now to adjust how fast my player moves. Now, I haven't actually applied this move speed anywhere. I've just declared it right here. So what we need to do is we need to come down to where we set our velocity, and we need to set it equal to x times our move speed. So we're just scaling up our move speed so that before it was, now it's changing from -1 times move speed, so -1 times 5, so -5 to +1 times 5. So it can go from -5 to +5. So we can move faster. So that's great. We should be able to test that and make sure that we can zip around the screen. There we go. Moving faster. See a little bump when we're moving on the time up. We'll fix that in a later session. Okay. All right. Cool. So we can move side to side. That was one of the big goals that we had for this one. The other one was to be able to jump. Okay. Now jumping, if you remember, is also an input that we can get. So we're just going to add a conditional statement that says if we push that button, if we push the jump button, then we're going to jump. Okay, so we're going to say if input dot get button down, parentheses, quotation marks, jump, and then our if statement also needs to have its own encapsulation. It doesn't end in a semicolon, it has its own encapsulation. So remember, semicolons are an end of a thought, right? It's the end of a single process, the end of a single procedure. Here, if statements are much more complex. We could have 100 lines of code inside this if statement if we wanted to. And so we don't want to end the if statement right here with a semicolon that says, no, I have a different way of telling you where I start and end. That is the encapsulation. Okay, so if statements don't use semicolons, they use curly braces to show their encapsulation. And inside our if statement here, we're going to jump. Okay, so we're going to get another vector 2. This is going to be called jump force. Vector 2, so we're going to just build a new one, and we don't want to move anywhere. We don't want our jump to move us on the x direction. We want our input to do that, our horizontal axis input. Instead, we just want to move on the y axis. So we're going to say jump force is equal to this vector, 0, 100. This number will change in a few minutes. Okay, and then we're going to get our rigid body 2D component just like we did above. And here we're going to call the add force function. So we're going to add additional force to our player that's going to be equal to our jump force. So when we press the jump button, then we're going to add that force. Okay, so that's great. We should be able to switch back to our Unity project. Now we should be able to move side to side, and we should be able to jump. But there's a problem. I can fly, right? So this is how Flappy Bird was made, right? So if we think if I set this to like 400 or something like that, I can come back here and I can push play and imagine that instead of moving side to side like this, I just had it add force. Now I'm playing Flappy Bird, right? I just had it moving constantly in one direction instead of using the player input. Oh look, I'm playing Flappy Bird. Oh, I died, right? So that's not great. And we can see why that happens right here, because we don't have anything that checks to make sure that we're actually on the ground, or that we should be able to jump, other than saying we press the jump button, right? So that's not ideal. Also, this variable is very not adjustable, so having it just set as a hard-coded value right here is not very good. So we want to do just what we did with our move speed and put another variable, float jump speed, okay. I'm going to come down here and I'm going to change this value to be my jump speed instead. So now I have this variable. It should be changeable in the inspector so that I can just modify it there instead of having to open my script. These are just knobs that we'll be able to change as we play the game to make sure that we can actually make all of our jumps. Now, we need to fix the multi-jump problem. Okay. There are a ton of different ways to deal with this. You can make it so that you can only jump if you have like a feet object. You can only jump if your feet are touching the ground. You can make it so that you basically draw a line down from you, and if that line hits an object, then you'll be able to jump. The easiest way for us to sort of get off the ground here, pun, is to have a collision. Basically say, if we collide with something as the ground, then we're going to reset our jump counter, and we're going to have a jump counter that basically says, whenever I press the jump button, we're going to increase our jump counter, and as long as our jump counter is less than some other value, our maximum number of jumps. So if you only want to have one jump, then you say jump count would be 1 and max jumps will be 1. Then we'll be able to jump. So here's how we are going to do that. We're going to create two more public variables here. We're going to create a public int jump count. We're going to start this at 0, and then we're going to create a public int max jumps. I'm going to set this equal to 2. So what this means is that I want to be able to jump 2 times. And so I'm going to start at 0 because I haven't jumped at all. Then I'm going to jump, and I'm going to increase jump count. I'm going to jump and jump again, and then I will not be able to jump a 3rd time. So that's how that's going to work. We're going to come down into our code here. We're going to modify our if statement. So we're going to come in between these 2 parentheses, and we're going to add another condition. We're going to say and. So if we press this jump button and, so 2 ampersands here, we're going to say and if our jump count is less than our max jumps. So jump count is less than our max jumps, meaning that we still have jumps to give, and we're going to jump, and then we're going to come inside our if statement here, and we're going to say jump count plus plus. Okay, this plus plus says that we want to increase it by 1, so we're going to say this value starts at 0. If we press the jump key, then we're going to jump, or if we press the jump key, jump count is 0, max jumps is 2, so we can jump. Jump count becomes 1. We press the jump button again. 1 is less than 2. We jump again. We add the force. Jump count becomes 2. If we press it a 3rd time, then we see, okay, we press the jump button, but this jump count will be 2, and 2 is not less than 2. So then we won't go into this code a 3rd time. Okay. So now if we save this, we should see, we come back into our game, we should see that we can jump again, and we can't jump a 3rd time, or any other times ever. Well, that's a problem. This is because we have never reset our jump count. The thing that makes the most sense for us is to have something that basically says when we collide with the ground, then we get to reset our jump count. So really, really easy for us to be able to do that. but it takes a little bit of configuration for us to be able to do it. So if we come into our Unity project, what we're going to do is we're going to add a layer. It's called a layer. So all objects, if we select any object, there's a layer dropdown in the top right of the inspector window. And we see I've already added this layer in here that's called ground. If you don't have it, then you click on the add layer button. It'll bring you in here, and then see user layer 8. We want to put ground into that that field right there. So that layer 8 is going to be our ground layer. Okay. Anytime we collide with the ground layer, we're going to say, if we collide with layer 8, then we're going to be able to jump again. Then we go and select our tile map, our ground tile map, and we're going to set the ground layer to ground, so that these will be flagged as on the ground layer and will reset our jumps. Now, the only thing we have to do is to code it. Now, looks like for us is we need a function that doesn't run like start, because start only runs at the beginning of the game. It doesn't run like update, because update runs every single frame. We want a function that runs just when a collision starts. And so that means that we need to create a new function. So we need to come to the closing curly brace of update. We're going to go at the end of update, but before the closing curly brace for the class, because we want our function to still be inside the class. And we're going to come right in between those two. And we're going to create a new function that's going to be void on collision enter 2D. Okay. So this means on collision enter, you might have noticed that there were several on collision functions. If I see that there's on collision exit, on collision stay for 2D. These all have different times that they run. On collision enter will run if the collision wasn't occurring last frame, and it is now. So that's like a new collision occurred. Okay. What this means is my player was next to the wall the last frame, but now they actually hit it. So they just ran into the wall. Okay. On collision exit says they were in a collision last frame, and now they are no longer in a collision. So the collision has ended. Okay. And on collision stay runs every single frame that they stay in a collision. So last frame they were in a collision, and this frame they're in a collision. These all have different functions as to when we would want to use them. In this case, the one that we really care about is on collision enter. We just want to reset our jump counter whenever the collision starts. Right? We hit the ground, we want to be able to jump again. Very, very simple. Okay. So the other thing that you might notice here is that we have this stuff inside the parentheses, right? We haven't seen a function that has stuff inside the parentheses before. We have things like get button down is actually a function. We might not have realized it. Variable that's being given to us from this collision function. The way that I like to describe this is, if you get in a car accident, then you are given, there is a police report from that car accident. This is that report. This tells you who was in the accident, where did it occur, when did it occur, all that stuff. So, and then you'll have all the personal information of all the people that were in the accident and that sort of thing. So this allows us to get all of the different properties of the objects there. And the thing that we actually care about is, hey, what's the layer of the thing that we ran into, right? So what we're going to do in here is we're going to say if the collision game object layer equals 8, so that's the number of the layer that we set as ground in the settings. So we said if the thing that we ran into is on layer 8, and you might be asking, why the double equal sign here? And it's a really, really good question to ask. So if we have something like this, we should get an error. It says it cannot implicitly convert type integer to Boolean. So layer is an integer, and it's the if statement cares about a Boolean. It says, is this true or is this false? And the reason that this error occurs is we look at other places where we've used a single equal sign. A single equal sign is used for assigning a value, changing a value of a variable. Here we are changing the value of number to be equal to 27. If we do this here, then what we're trying to do is we're trying to change the value of the layer that we ran into to be 8. That's not what we want to do at all. We want to compare these values. We want to do a comparison. So a double equal sign does a comparison of those two values instead of trying to reassign the value like a single equal sign does. So that's why we have to use a double equal sign there. Okay. So if we compare these two values and they are equal, then we know we've run into the ground. Now we just need to reset our jump count. Jump count equals 0. That's it. Okay. We just make it so that anything we want to jump off of is on the layer 8, and then we can jump off of it. Okay. Now this should all work for us. If we come back here, we push the play button, we should be able to jump, jump. I can't jump a third time. As soon as I hit the ground, I can jump again. So now we can move side to side, we can jump around our level, and we can actually get some solid platformer movement here. We might notice as you're playing that you stick to the edges of platforms. We will talk about how to fix that in a later session. You might also notice that you glitch through the tiles every once in a while. This is because there's all those different colliders here. Sometimes if you hit it just wrong, you'll actually like slide in between the two and you'll land down in the bottom. Again, all these things we'll fix a little bit later, but we should have ability to move around and jump around with some basic platformer style input. And with that, there's just a couple other things that I want to talk about. All these values, if you want to make it that you only have one jump, you can change the max jumps in the inspector here, so that now I only have one jump, right? If you want to up the difficulty level of your game, you can do that. If you want to make it, really easy, you can increase the jump count to 10 or something like that. You can even, anytime that there's a variable like this in the inspector, you can type infinity. Oh. It's not letting me do it here. Okay. But anyways, because it's jumps as an integer, not a float. For floats, you can type infinity. So things like move speed, I can type infinity and it'll actually work. So if we wanted to be able to have infinite jumps, then we could do that by changing it to a float. Anyways, so that is some of the things that you can actually change here. Another thing that just so that you are aware, the gravity scale, usually the gravity scale in platformer games is actually higher than normal gravity in World. This is because if we actually play this, we see that the player kind of floats down to the ground. There's a lot of air time. And so in platformer games, you're trying to increase the amount of time that the player feels that they're actually like doing something, playing the game. You want to make it feel more snappy. You can adjust this gravity scale. Usually it's between like 2 or 3 in a lot of different platformer games. And then as you do that, you'll have to adjust the jump force and stuff in your player movement in order to be able to counteract that, because you are getting pushed down a lot more by gravity. So that is the gist of the platformer movement. I'm gonna zoom out here so that I can maybe get the whole script on the screen. Okay, that is the platformer movement script, 50-line script. I hope that you were able to follow along with that. And the next session we will be going around how to have enemies deal damage to you and that sort of thing. So I hope that you are able to show up for that.